Hey, Chem class, we're back again. It's homework 8-6 time. So go ahead and grab that out of your packet if you haven't already done so. So homework 8-6. This one it'll take you a little bit of time, but I don't think you'll find it to be terribly difficult. I will walk through it with you every step of the way. You'll be terrific. You'll also benefit from having your textbook open to pages 258, 259, and 260, and watch for the hidden extra credit in the video. Okay, so let's go ahead and get started. So first off, the vocab and skill builder are all in one place. Okay, so we're just going to answer these. These are not difficult. You should be able to find those really easily. Okay, so in your text, we start at page 258. Right here in the middle, we find out the definition for decomposition reaction. We find out electrolysis. Okay, a binary compound. Is in here as well. Sorry for the delay there. A binary compound is in that setup as well, so you can look for that. Also remember, you have a glossary in the back and also an index to help you find your way. Okay, so glossary and index are going to be really valuable tools if you don't have any other guess as to where to start. I'm still not finding the index. Okay, so maybe the glossary and the index are switched, but look in the back of your book to get some help for these. Okay, and a binary compound, you will find, you're asked not just what a binary compound is up here, but a binary compound in its decomposition. So if you remember last time, I showed you that a synthesis reaction is two or more things combining or synthesizing, because synthesis means combine, assemble, put together, something like that. Reaction is taking many things and turning them into just one thing. All right, so a decomposition reaction is going to be exactly the opposite. And in a decomposition reaction, we have one substance breaking down into its component pieces, two or more. Okay, so specifically, I could say that water, which we know as H2O, breaks down to form hydrogen and oxygen. Now, both of those are diatomic, so it's H2 and O2. And then we would go about balancing the equation to satisfy the law of conservation of mass. But this is a decomposition reaction. Now, it doesn't happen spontaneously, right? So we would maybe have to add electricity. Okay? And that would separate those. So that's an example of a decomposition reaction, when one substance decomposes into component pieces. So you have one thing breaking down into two or more. All right, and that's how we're going to recognize decomposition reaction. And I need you also to recognize that it's the opposite of synthesis. Okay, so a lot of times you might see these equations written with the double arrows, that the equation can work forwards or backwards. So just be aware of that. Okay, and then Joseph Priestley, you're going to find him near the bottom of page 259. He is not in bold. He's just kind of a mention there, but it talks about what his contribution to chemistry is. Okay, for 7 and 8, all right, you're going to turn to pages to page 260, and it talks about specific decompositions. All right, specific decompositions. So number 7, it says when a metal chloride is heated, it decomposes to produce, right? So you're going to look right here where the big green letters say decomposition of metal chlorides. And take a look at what it says it decomposes into. It decomposes to produce, da 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 da. You know, like it even says it decomposes to produce, da 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 da. Okay, and then when a metal carbonate is heated, it produces, so that's decomposition of metal carbonates. Use the information right at your fingertips. Okay, not at all difficult, but you do have to pay attention. Okay, I know you can do that. Now our graphic organizer. Okay, and you can put that on the back. Look at all the real estate on the back of the page. All right, you're going to create a chart to record the different types of reactions. It wants synthesis, decomposition, single replacement, double replacement, and combustion. We haven't done all those yet, but we're looking ahead. And then the instructions are, write a general equation and a specific equation. Okay, so this can look however you want it to look. Make it legible for me, but other than that, it can look how you want it to look. So I have one started here, right? My synthesis reaction looks like this. My decomposition reaction looks like this. And the only thing I would need to add to that then is my specifics. So my decomposition reaction, that's a specific reaction that shows decomposition. For synthesis, maybe I would say H2 plus O2 yields H2O. Balance the equation and you're good to go. But what's really cool is that in each section, you have examples, okay? So right here, the big red letters say synthesis reactions. So that's going to be synthesis. This is your generic equation. And right here is a specific one. Boom, you're done. Move on to look for the next big red heading. Okay, so decomposition. Check it out. Here is your generic. And look, here's a specific. Moving on, single replacement. You have 2 generics. Write them both down. Here's an example. Okay, I'm not asking you to reinvent the wheel. Just find all of the red headings. All right, combustion is the final one. Give an example. Now, combustion doesn't have a generic because combustion reactions are pretty much all the same. Okay, so you know, kind of do the best you can with that, but they're pretty much all the same. So you won't have a specific generic because they really look all of the same. Okay. And we will get to combustion reactions later, but that's going to help you all the way through the graphic organizer. Don't make it very difficult. It might take you a little bit of time, but it's not a whole lot of brain power. It's just taking the information from the text and putting it into a table that makes sense to you, and you can convey that to me. All right, and then your standardized test prep, you're looking for a decomposition reaction that is correctly balanced. Okay, same deal here. All right, so it's hitting 2 high notes there. It's reviewing how to balance equations and asking you to identify this reaction. I'm sorry, this one's not decomposition. This one's just reviewing balancing. Okay, right, so take your inventory left and right, add your coefficients where they are needed, redo your inventory, and you're good to go. All right, so today's extra credit. All right, I want you to look immediately to your right and find an object that is to your right. So I'm going to tip the camera. Can you see what's to my right? Check it out. I've got a rock. I've got some pens, markers. I've got a squishy stress reliever. So my item that is to my right is a stress reliever shaped like, you got it, a brain. So I don't know whose brain I'm squeezing when I'm stressed, probably my own. But my item to my right is a brain. What's yours? And I'll give you extra credit on homework 8-8. That's not right, 8-6. All right, homework 8-6 gets 2 points extra credit if you tell me what's to your right, given that my right holds a brain. You guys have a great day. I will catch you again next time where we work on homework 8-7, and we'll just do this all again. Let me know if you have questions. I'm here to answer those. Have a great day. Bye.